Part 3. Multiplying and dividing rational expressions. We'll start with multiplying, we'll do some examples with that, and then we'll move into division of rational expressions. Okay, so again, multiplying rational expressions is just like multiplying fractions. Top times top, bottom times bottom. Again, you can simplify before you multiply or after, but don't forget your answer should always be in the simplest form. I like to simplify beforehand. It just makes simplifying easier because now you have bigger terms if you multiply first. Don't forget, NPVs must be found for all denominators. All right, let's get rolling. In our first example, again, we're going to multiply, express answers with positive exponents, so there should be no negative exponents, and find NPVs. Okay, let's go with 100 and 250 are both divisible by 50. So 50 goes into 100 2 times, and 50 goes into 250 5 times. 27 and 81 are both divisible by 9. So, are both divisible by 27. Okay, so they're both divisible by 27. So 27 goes into itself once. 27 goes into 81 3 times. Okay, now, as far as x's go, I have x to the 5th and an x on the top, so that's x to the 6th. And on the bottom, I have x to the 9th. So I have more on the bottom. How many more? 3 more. So that's going to give me x to the 3rd on the bottom. Okay, what about y's? I have a y times y to the 5th, so that gives me y to the 6th. And on the bottom, I have y to the 4th. So that puts me at 2 more y's. Again, dividing, we subtract the exponents. So that gives me y squared, and that goes on the top. Okay, so let's multiply then with what we've got. 2 times 3 is 6. And we had a y squared on the top, all over. 1 times 5 is 5. And we had an x cubed on the bottom. All right. Now, please note that we again have denominators, so we have to find the NPVs for each. 27y to the 4th cannot be 0. Again, it's a monomial, so divide by 27 and 4th root, y cannot be 0. Do the same thing with the 250, x to the 9th, can't be 0. Again, divide by 250 and 9th root x, it's a monomial, so we just know that x can't be 0. All right, that's that guy. So there's my simplified value, and of course, those are my NPVs. All right. Let's do the next question in a different color. All right. So in the example here, I'm going to factor. So I can factor the numerator. I can take a 2 out, so I would be left with 7x plus 1 times 8 over. I can factor an 8 out and be left with x minus 10. And I can factor a 10 out and get 7x plus 1. From that guy. Now, if you notice, there's a 7x plus 1 on the top and the bottom, so they both cancel. I have an 8 on the top and the bottom, and they both cancel. And 2 goes into 10, 2 goes into 2 once, and into 10 5 times. So, on the top, I just have 1. And on the bottom, I have 5 times x minus 10. Okay, NPVs. 8 times x minus 10 can't be 0. Divide by 8 becomes x minus 10, can't be 0. And add 10, x cannot equal 10. So there's one NPV. All right, and we also have 10 times 7x plus 1 cannot be 0. Divide by 10, that's 7x plus 1 can't be 0. Minus 1, 7x cannot equal negative 1. And divide by 7, x cannot equal negative 1/7. All right, so there are my NPVs, and there is my simplified rational expression. Okay, and we'll do a couple more of these, and then we'll move on to some division. Let's try that color. Okay, again, we have to factor. So the top 6v minus 42, I'm going to factor out a 6. It's my greatest common factor, and I'm left with v minus 7 over. In the denominator, I can factor out an 8, and I can also factor out a v. So 8 goes into 45 times. I got rid of one of the v's. Plus 9, also got rid of a v. Times 5v plus 9. I can factor 3 out of here. So that's 3 times v plus 3 over. And on the bottom, I can factor out a 18. And I'm left with v plus 3 on the bottom also. Okay, what's the same on top and bottom? Well, I have a v plus 3 here and a v plus 3 there, so they can cancel. I have a 5v plus 9 and a 5v plus 9 because they can cancel. Remember, you can cancel exact same binomials, okay? I have 6 times a 3, which gives me 18. That 18 on the top cancels with this 18 on the bottom. So they're all gone. And there's nothing else on the top but v minus 7. And there's no v minus 7 on the bottom. So I think that's it. So we get v minus 7 over 8v. Okay, NPVs. So here I have one, there I have one, and there I have one. Because remember, 18 is a constant, so it does not have a variable. Okay, so 8v cannot be 0. I divide both sides by 8. V cannot be 0. Okay, 5v plus 9 cannot be 0. So subtract 9, so 5v cannot equal negative 9. And divide by 5, v cannot equal negative 9/5. Okay, and last, v plus 3 cannot equal 0. And subtract 3 from both sides, so v cannot equal negative 3. There are my NPVs. And of course, this is my simplified rational expression from multiplying. All right, last but not least, letter D. Let's try green. All right, so we're going to factor out a GCF here. So 6a plus 20, we're going to factor out a 2. So that becomes 2 times 3a plus 10. And on the bottom, I can also factor out a 2. So that becomes a minus 2. Times, I can factor out an 8. So that becomes a minus 4. And I can factor out a 2. That becomes a plus 7. Times, I can factor out a 2a squared. And I'm left with a minus 2. And I have, that's already factored. All right, now that everybody's factored, kind of want to remember, like, you know how the commercials used to say, safety first? Well, now you have to remember to factor first. Okay, so 3a plus 10, there's one on the top, there's one on the bottom, it can go. A minus 2, one on the bottom, and one on the top, so that can go. A minus 4, one on the top and one on the bottom. These 2's out front can go. This 2 goes into that 2. And I think that's it for canceling stuff out from top and bottom. Remember, when you do cancel, it goes into itself once, but multiplication by 1 just gives you the value. So it's you don't necessarily need to show the ones. All right. On the top, I got an 8 left and an a squared. So 8 times a squared is 8a squared. Over, and on the bottom, the only thing I have left is an a plus 7, it looks like. And that would be my final simplification. Okay, let's take all our denominators and find our NPVs. So here I have a minus 2. So a minus 2 cannot be 0. So add 2 to both sides. A cannot equal 2. Okay. I have this one, a plus 7 cannot be 0. So subtract 7 from both sides. A cannot equal negative 7. 0 take away 7 is minus negative 7. I have a minus 4 cannot be 0. So I'm going to add 4 to both sides. A cannot be 4. And last but not least, I have 3a plus 10 cannot be 0. So I'm going to subtract 10 from both sides. 3a cannot equal negative 10. And divide both sides by 3. A cannot equal negative 10/3. All right, that is it for multiplication. And we'll move on to the next page and try some division. Okay, when we're dividing rational expressions, again, we do something called flip and multiply. Flipping means to take the reciprocal of the divisor. The divisor is the second expression, or if they're written top over bottom, it is the denominator of them, okay? All right, so in this question here, we have 9 over 2n divided by 7n over 8n squared. So this is my second term, this is my divisor, so I'm going to flip and multiply by it. So that becomes 9 over 2n times 8n squared over 7n. And now I can simplify. Okay, I have n times n on the bottom. I have an n squared on the top, so all the n's will cancel. 2 goes into 8, 2 goes into 2 once, 2 goes into 8 4 times. And that's it for simplifying. 9 times 4 is 36. 1 times 7 is 7. Now, of course, I have letters in the denominator, anywhere in the denominator. So I have 2n, I have 8n squared, but this 7n, if you'll notice, also ends up in the denominator. So I have to find it for all of them. Fortunately, they're all monomials, so it really doesn't matter which one I pick. I'm going to get the same value for n. Divide both sides by 8. I get n squared cannot be 0. And square root 0. N cannot equal 0. Would it have mattered if I chose 2n? Nope. 2n can't be 0. N can still not be 0. Or if I chose 7n, again, divide both sides by 7. 0 divided by 7 is 0. So it doesn't matter which one I picked. They're all monomials, so all of them would have given me n cannot be 0. Okay, part B, again, we need to factor. Okay, so in the numerator, I can take out an 8 and an m squared. I'll change my pen color here. Try that guy. Okay, so I'm going to factor out an 8m squared. 8 goes into 56 7 times. And I can only remove 2 of the m's, so there is one still there. All right, 8 goes into 32 4 times, and I remove both of the m squared. On the bottom, I can also factor out an 8, but just time 1m this time. 8 goes into 45 times. M into m squared goes m times. Plus 8 goes into 16 twice. M into m goes once. Again, this is division, so I'm going to multiply by the reciprocal of the second term. So, and I'm going to factor here too. So this guy's going to become my numerator, and I can factor out an 8m. Okay, and I get a 5m plus 2. 8 goes into 45, 8 goes into 16 twice, and this becomes my denominator. I can factor a 5 out of there, and that gives me 7m plus 4. Good, once I've factored and I've taken the reciprocal and multiplied, I can now start canceling. Well, this whole denominator is the same as this whole numerator. I guess I could have done that before I factored. Okay, and 7m plus 4, there's one on the top and bottom. That only works, remember, because this is multiplying. Okay, when we get into adding and subtracting later, you have to do different rules. But for multiplying and dividing, as long as there's one on the top, one on the bottom, not a problem. Okay, that's all for canceling. So I'm left with 8m squared on the top and a 5 on the bottom. Okay, let's find any NPVs. Remember, this guy here and this guy here are the same, so I don't have to go through and do that twice. So I just have to do this once and this guy here. All right, so 8m cannot be 0. Divide both sides by 8. M cannot be 0. We have 5m plus 2 cannot be 0. I'm going to subtract 2 from both sides. 0 take away 2 is negative 2. And divide both sides by 5. So m cannot equal negative 2/5. And 7m plus 4 cannot be 0. Subtract 4 from both sides. 7m cannot equal negative 4. And divide by 7. M cannot equal negative 4 over 7. So those are my 3 NPVs. And this is my simplified expression after dividing. Okay, a couple more fun examples to go, and then you're off to work on your own. Let's try this green. Okay. All right. So first thing we're going to do is factor out a GCF from the top. So that is a 7. And that would give me 3k squared minus 2k minus 1. On the bottom, I can factor out a 5. So that gives me 3k squared minus 2k minus 1. Again, division, so I'm going to change that to multiplying. And I'm going to flip these guys around. Take the reciprocal. So I can take a 40k out of here. And I'm left with k minus 1. Okay, and again, you can multiply that back in to check and see if you did it right. And the last one, I can factor out a 7. And I will get k squared plus or minus 8k plus 7. Okay, so far so good. Now, 3k squared minus 2k minus 1 is the same top and bottom here and here. So I can get rid of those. Okay, the 7s will also go because I have one on top and bottom. And 5 goes into 40 8 times. So I'm left with 8k times k minus 1 over k squared minus 8k plus 7. Now, technically, you guys don't have to factor trinomials. So this is more simplified. I'll show you how that works. But you would never probably get that on a test. So as far as you're concerned, this would be acceptable. Okay, and that is k minus 7, k minus 1. Okay, because k times k is k squared. Minus 1k minus 7k gives me minus 8k's. Negative 7 times negative 1 is positive 7. And now if you notice the k minus 1's cancel, and I'm left with 8k over k minus 7. So again, for you guys, this would be an acceptable answer. Okay, but if you remember how to factor trinomials, then you could actually bring it down to this guy. Okay, any denominators we have, we can find non-permissible values for. Okay, so we have k minus 7 can't be 0, so k cannot equal 7. And we have k minus 1 can't be 0. K cannot equal 1. Okay. And I think that is all for you. Oh, right. This guy used to be in the denominator. So 40k cannot be 0. So k cannot equal 0. Okay. Because we divide both sides by 40. All right. Looking good. I think that's it now for denominators. Now this guy here, 3k squared minus 2k minus 1, you can't factor, so you don't have to worry about it for its NPVs. So there you go. And last example. We'll go back to good old blue. Okay, now this is kind of a funny one because I have a fraction going on with some fractions. So on the top I have 4x minus 3 over x. So if I have 4 over 5, for example, I'll take away 3 over 5. The denominators are the same, so I can just subtract the numerators. So that becomes 1 over x over 16 over x squared. Remember that this is my divisor, so I'm going to flip and multiply. So that gives me 1 over x times x squared over 16. Okay, so again, I took the denominator and flipped it and changed my question from division into multiplication. X goes into x squared, 1x times. And top times top is x, bottom times bottom is 16. Okay, for NPVs, I have x's on the numerator here, but they're on the denominator of the numerator, so I have to find the NPVs for that. So that's just easy, x can't be 0. And here I also have an x in the denominator, so x squared can't be 0. Square root both sides, again, I get x can't be 0. So that's the only NPV I have to worry about there. All right. Hope you had fun. Remember, multiplying top times top, bottom times bottom. And for division, just change it into multiplication. So take always the second fraction or bottom fraction take its reciprocal, and change it into a multiplication question, and it's just as easy as the last page. Hope you enjoyed that. A couple more sections to go, but before that, page 238. Don't forget to show your teacher when you're finished.